Welcome back to the Deep Dive, where we take the sources you share with us and distill them down to the most critical insights, fast. Today, we're tracking some of the most impressive athletes on the entire planet. Migratory birds.
It's an incredible
It,
topic.
it really is. I mean, just think about the scale of what these creatures achieve. You're talking about feathered voyagers capable of these unbelievable feats of movement.
Spanning entire geographic regions, crossing oceans, traveling between hemispheres.
Exactly. Their whole life strategy, where they go, when they go, how they survive, it's all intrinsically linked to these really precise environmental cues.
Things like seasonality, climate, the shifting availability of resources.
But here's the core tension, laid out in the research we looked at. Those environmental cues are changing dramatically, and they are changing fast.
They really are.
Birds are increasingly finding themselves exposed to totally inhospitable and just novel environments because of anthropogenic threats.
Okay, let's unpack this.
Yes. Let's figure out what these massive global shifts, climate change, urbanization, habitat loss, what all this means for avian life and for conservation efforts worldwide.
It's a hugely important mission for this deep dive because what we're witnessing is it's really an ecosystem-wide stress test.
The stress test, I like that.
Our source material is grounded in a 2024 editorial by researchers Benjamin Zuckerberg and Frank Ilesort. And it introduces a whole research topic dedicated to this immense challenge in frontiers and bird science.
And what's the headline from their work?
They clearly establish that the natural pathways, the migration corridors, and the crucial stopovers that millions of birds rely on every year are under intense pressure.
And when we say anthropogenic threats, what's in that bucket?
It's the whole toxic mix. We mean global climate change, massive pollution, widespread habitat degradation, and of course, encroaching urbanization.
So everything.
Pretty much. And the result is profound implications worldwide. It's not just affecting where birds live, it's impacting their behavior, their ability to breed, and ultimately their long-term survival.
And before we get into the specifics of those threats, I want to take a moment to marvel at how we're even able to track this global phenomenon in the first place.
Right. The technology.
The study of avian migration has always hinged on technology, and some of the early tech was, remarkably lo-fi, but just brilliant.
Absolutely.
Think back to the foundational studies. We're talking about researchers like Emlyn in 1970, who was essentially sticking caged birds inside planetariums.
To figure out how they use celestial navigation, yeah.
Yeah.
Mapping the stars to guide their journey. It's incredible.
Or Walcott in 1974, strapping tiny magnets to birds to understand the role of the Earth's magnetic field and, grounding their navigation. That was absolutely groundbreaking ingenuity for the time.
For its time, for sure.
But here's where it gets really interesting. You fast forward half a century from those planetariums and magnets, and the technology available now has just absolutely exploded.
Oh, it's a different world.
We've widened the circle of investigation from a small lab experiment to, a massive global tracking system.
It's an astronomical leap. We've moved from banding legs and putting magnets on their heads to the era of geolocators, these tiny miniature tracking devices.
Okay, wait, how tiny are those geolocators now? Are they basically wearing a microscopic Fitbit? The engineering for that alone is mind-blowing.
Pretty much. They're small enough to be attached to medium-sized passerines without disrupting their flight.
Wow.
We also have advanced weather surveillance radar that can detect and track the movement of entire flocks of migrating birds and these massive citizen science efforts where people all over the world report their sightings.
But the real game changer isn't just the device, right? It's the data processing.
Exactly. These new data streams are paired with seriously advanced statistical modeling. This combination allows data-driven science to take a much more significant role in advancing our understanding and conservation efforts across multiple scales.
That sounds a little like academic jargon, though. If you say taxonomic, spatial, and temporal scales, what does that actually mean for you, the person listening to this?
Yeah, fair question. It's just a scientific way of expressing total coverage. It means we can track all types of birds, not just a few. That's taxonomic.
Okay.
We can track them everywhere on the globe. That's spatial.
Right.
And we can track them all the time for the entire cycle of their lives.
Yeah.
Not just when they leave or arrive. And that's temporal.
That's the huge shift.
It's a fundamental shift from the past, where we had these massive knowledge gaps between seasons. We can finally start connecting the dots globally, year-round.
And the first dot that is, it's screaming at us right now, is global climate change. This is the single most significant driver affecting migration patterns. And the most immediate issue it creates is one of timing.
The timing, yeah.
Ecologists call this timing issue phenology, but let's make it simpler. Think of it this way. The bird has a biological calendar. It knows when it should fly north based on cues like day length.
Right.
But rising temperatures have fundamentally altered the timing of seasonal events in the north. Things like when specific flowers bloom, when trees leaf out, or crucially, when the insect populations emerge.
And migratory species rely on absolute precision. They need to arrive at their breeding or wintering grounds when food availability is at its peak.
Right when the food is there.
If spring arrives weeks early or the peak insect population, the primary food for baby birds hatches and then vanishes before the adult birds even get there, you create what the research calls mismatches in resource availability.
They arrive at the buffet and it's already closed.
Precisely. And the consequence of that is immediate. Decreased reproductive success, fewer babies survive, or sometimes the parents themselves don't survive the energy drain. It's a feedback loop that's intensely damaging to population numbers.
And this brings us to a major critique of the models we've been using up until now. Because the issue is so complex, researchers have found that existing models often suffer from a static view.
A static view, yeah. Essentially treating climate as the only factor constraining where birds can live.
Which we know isn't true.
That's right. A review by Stevens and colleagues highlighted this. They argued that the current state of ecological forecasting often fails to capture crucial, real-world dynamics.
Like what?
How seasonal interactions affect the bird, the immense variability in weather year to year, and critically, the non-climatic threats, things like pollution and development that static models just ignore.
So the old models basically assume the birds teleported between seasons, right? They were fine during the summer, they were fine during the winter.
Yeah,
But we had no idea what happened to them on the road or how one season impacted the next.
that's a great way to put it. Most current studies only model range shifts during a single season, and they often focus just on North America or Europe.
So what's the fix?
The crucial leap, according to Zuckerberg and Lasorte, is advancing something called full annual cycle distribution models.
Okay, what does that do?
These models have to specifically account for migratory connectivity. That is, which breeding population links up with which non-breeding population and integrate those non-climatic threats. If we don't model the entire year, we're only solving one quarter of the puzzle. It's like trying to predict a football season based only on the first game.
That idea of migratory connectivity is fascinating. It means that, say, the pollution in a wintering ground in South America could directly affect the reproductive success of that same bird when it gets to Canada 6 months later.
Exactly, it's all connected.
Now, let's shift focus from the timing of the seasons to the physical act of moving itself. Beyond timing, climate change is actively altering the weather patterns that birds use for navigation.
Right, things like prevailing wind direction, wind speed, the timing of major weather systems.
And that's a huge physical challenge.
It is. Birds, especially those making long transoceanic flights, they rely on predictable weather windows and consistent tailwinds. They plan their routes based on these prevailing atmospheric currents.
But those are getting disrupted.
When those patterns are disrupted, when a reliable tailwind suddenly becomes a strong, unpredictable crosswind, their traditional migratory routes get thrown into chaos.
And the immediate cost is literally physical energy.
Yeah, they need to use significantly increased energy just to complete the journey, sometimes burning their entire fat reserves just to stay on course.
Yeah.
It's the difference between cruising on an escalator versus climbing endless stairs.
Wow.
Exactly. And while some birds may try to adapt by altering their routes or changing the specific grounds they use, that very act of adaptation pushes them into new territories.
Making them vulnerable to novel environmental challenges they weren't evolved to deal with.
That vulnerability is exactly what a team led by El Hindi studied. They chose to focus on a frequently understudied area, the globe South America.
Okay.
They looked at 2 distinct South American flycatcher populations breeding at different latitudes. And they used that cutting-edge data from the light-level geolocators.
So they got hard data on where these specific groups actually travel and live?
Yes. They used that real-world data to model current distributions and then project future geographic distributions under various climate scenarios.
And the findings?
The findings were stark. The modeled projections identified significant losses in geographic distributions for both populations under future climate change. They simply won't have the geography or climate they need to thrive.
So their homes are just disappearing.
But here's the critical nuance for you, the listener. The magnitude of these projected changes vary distinctly, not just between the two populations, but between the seasons.
Oh.
One population might suffer massive losses in its breeding territory, while the other faces its biggest threat in its wintering habitat.
This raises an important question then. If risks are so regionally and seasonally varied, we can't apply a blanket conservation plan across an entire species.
No, you can't.
The idea that we can just protect a single massive area and call it a day is obsolete.
It is obsolete. The results emphasize the critical need for highly tailored conservation strategies that specifically consider both seasonal dynamics and regional variation. Different bird populations, sometimes within the same species, are facing completely different existential risks depending on which leg of the journey they are on.
So if climate change is attacking their schedules and their navigation, what happens when they finally land? Let's transition to the direct pressure from human land use.
Right. Deforestation, widespread agriculture, and of course the ever-expanding footprint of urbanization.
These activities lead directly to habitat fragmentation and degradation, meaning the ecosystem they need to survive is chopped up into isolated, less healthy pieces.
And what's often most critical for migratory species is the loss of stopover sites.
The rest stops.
This is the bird equivalent of a highway service station. Imagine driving cross-country and every gas station or restaurant is gone. You're trying to fly thousands of miles and you suddenly have nowhere to land, nowhere to rest, and nowhere to refuel adequately.
That loss increases stress, starvation, and mortality drastically. They are literally running on empty halfway through the marathon.
And the effects don't just disappear when the bird finally makes it to its destination. The degradation of their breeding and non-breeding habitats can negatively affect survival and fitness.
And in some cases, these negative effects can carry over into subsequent seasons. It's an ecological debt.
That's the term for it.
That phrase, carry over, is so powerful. It implies that a negative decision a bird makes in July is impacting its ability to succeed the following May.
We see this clearly demonstrated in a fascinating study by Barbosa and colleagues. They used banding and tracking data for another South American flycatcher species to look at exactly this long-term impact.
What did they find?
They found a definitive negative correlation. Birds were less likely to return to their nest sites in the subsequent year if they had bred in large cities the previous year.
Wait, are you saying a bird that chooses a nest in a noisy, polluted, stressful city park, perhaps because its natural forest habitat was destroyed, it's making a decision that will literally reduce its chance of survival or success a full year later?
That's what the data suggests. It feels like a multi-year ecological debt. It's not just a challenge for that season, it impacts their ability to successfully migrate and breed the next year.
Wow.
Precisely. The authors note that with ongoing land use change associating with these suboptimal habitats across the annual cycle is likely to generate compounding effects on survival and fitness. It is a slow, accumulating burden.
So if they're stressed and underfed in the city,
They leave for migration in poorer shape, which makes the journey harder, which makes their arrival at the wintering grounds more difficult, and thus makes their return journey less likely. It adversely affects the species' long-term persistence.
it paints a dynamic, terrifying picture. These aren't isolated events. They are interconnected failures across continents, linked by the movement of one tiny bird.
It's staggering when you think about it that way.
So what does this all mean? If we synthesize the evidence from this editorial and the research they highlight, the takeaway is clear.
It is.
Bird movements and migration are not passive processes. They are intricately linked to global environmental changes, climate, land use, weather in this complex and dynamic fashion.
And understanding these nuanced full annual cycle relationships is absolutely essential for implementing effective conservation strategies.
Right.
But beyond conservation, there's a broader societal implication here. Birds have long played a role as incredibly visible and charismatic bioindicators for ecosystem health.
They're the canaries in the coal mine, but for the whole planet.
They are. They are often the first and most visible casualties of environmental disruption. They literally show us in real time what our actions are doing to the planet.
So this research isn't just for the birds.
Not at all. Consequently, the rigorous, data-driven insights generated from these efforts, understanding migration timing, route changes, those alarming carryover effects, will play a crucial role in informing the public on how our entire natural system is being affected by global change.
And awareness is the first step.
With greater public awareness and the compelling nature of these findings, The chances that effective global change mitigation measures will be developed and applied for birds and other species will inevitably grow.
That idea of compounding carryover effects is really something to think about. If the immediate environment a bird chooses, like an urban nest site, has measurable negative effects that literally follow it and reduce its ability to successfully migrate and return a year later, that just raises massive questions.
Hmm,
What other subtle, everyday environmental pressures might be causing similar long-term carryover effects that we haven't even measured yet?
that's the question, isn't it?
Think about the unrecognized compounding effects you might observe in your own local natural systems, not just on birds, but on insects, plants, or even the water supply. It's all connected. And that's something to keep in mind the next time you see a feathered friend passing through.